right, well, let's go to the very beginning here, shall we? I'm gonna go all the way up and throw in that slide. What are we looking at here?
Is that a nuclear reactor?
It is part of a nuclear reactor. It is the reactor core specifically, and control rods, etc. So I'm not going to talk too much about that. My colleague, Petty Officer Willhoite, is a nuclear reactor mechanic, so I'm going to let him do that. However, we'll just go. Let's do quick introductions. I graduated from BYU, a little bit south of here, several years ago. Went into the workforce, and then in 2010 went into the officer candidate school ranks and came out as an ensign in the U.S. Navy. I served aboard a couple of ships. One in started in Maine. It was a brand new ship out of the shipyard, and we sailed it around through the Panama Canal to San Diego, and I served there for a couple years on board that ship. From there, I went to Pearl Harbor, Hawaii, and served on a different class of ship and a cruiser. My first job was the communications officer and one of the missile officers. And my second job, my second ship, was as the damage control and hull repair officer. So one was IT, communications stuff, and the other was engineering. So different roles. From there, I went to Navy Networks, and that was in Virginia. And I managed 22 global telecommunications stations for satellites, radio, and network communications for a year and a half. From there, I went to the Navy Reserve, and then now I manage officer programs as well as enlisted divisions here in the Boise and the Reno region. And I will turn it over to Petty Officer Willhoite for his intro.
All right, so I'm Petty Officer Willhoite. I'm actually an enlisted nuclear mechanic. Enlisted out of Spokane, Washington back in 2012. Went through boot camp, went through the nuclear power school there in Charleston, South Carolina. And after that, spent 4 years on the John C. Stennis out of Bremerton, Washington. Did 2 deployments out there. Started from bottom and left as the lead petty officer of my division. Maxed out all my nuclear quals that I could enlisted side in those 4 years. And then after that, I've been recruiting out here in Boise since May of last year. And this last month, I came over with Mr. Mosier to start working officer side. But these are a lot of the cool things that I did on my ship. So starting top left, so what we did is we parked in the South China Sea in the Marianas Trench, and we all got the ability to jump off the ship, which was pretty nice. Halfway through deployment, it was like 75-degree water, and just went for a swim call. The other places, so the middle and the top right, so I did both of those. Those were in Pattaya Beach, Thailand. The top right one is actually the tiger park that's there. In that enclosure is about 30 tigers walking around that you can interact with and pet, and they have their full teeth, full claws, everything like that. But they're trained from the time that they're young not to be aggressive. And then went on a elephant safari while I was out there through the jungle. And then the bottom left picture, I actually stayed in that hotel in the background that looks like a ship. It's the Marina Bay Sands in Singapore. And then the bottom right, that is an almost exact picture of the taxi that I took while I was in Dubai. And that was some of the fun stuff I did on deployment. All right, so this was my chart, or this is the way I went through the nuclear power enlisted pipeline. Okay, so started off top left, enlisted. I got an enlisted bonus. Went through boot camp there in Great Lakes, Illinois for 2 months. After that, went through my A school where I learned how to be a nuclear mechanic, but that's where people can become ETs or electricians there. After that, you go through nuclear power school. So what they do is they took they took MIT's program and consolidated it from the 4-year nuclear technologies program into 6 months. So it's pretty much like drinking from a fire hose for 6 months, but you make it through. After that, you do your journeymans at prototype. So that's 6 months of actual operation. You're there operating reactors, operating pumps, valves, whatever you're doing, with an instructor looking over your shoulder so that you don't mess it up. After that, you receive your Department of Energy certification to operate a nuclear reactor in the United States. And then if you're a machinist mate, you have the ability to go into nuclear welding, or you can go into ELT, which what that is it's the chemistry control of the water on board the reactors and also all the radiological controls with it. From there, you go to a submarine or a carrier like I did, and then at your 2-year point, they offer you a lot of money to extend your contract from a 6-year to an 8-year, which is what I did and why I'm here. So.
All right. So we've talked a little bit. I want to talk with you, and I want to hear from you, each of you. I think there are 9 here today, right? Is that correct? Looks like it. So, open-ended question. What's engineering? Let's hear it.
Tarek says applied physics.
Okay. Applied. I like the word apply. Keep going.
Gus says problem solving.
You can verbalize too. You don't have to chat. We're good with talking.
That would actually be good, guys, if you can use your mics.
Yeah, I can wait. I've got all day. I'm good.
I guess I would say just being innovative and coming up with solutions to problems that need solutions.
I like it. I like that one probably the best. Let's keep going.
The application of a bank of knowledge to basically solve new and novel problems. I mean, everyone else's answer just rolled into one, I guess, but yeah.
So I read some of your responses. So your instructor sent out that email to you, and I read a few of them. And that prompt was from me, why engineering? So let's do that. Why engineering? At least for you. Why engineering for you?
So for me, I would say that I chose engineering just because I've always loved building things and creating things. And I mean, I'm good at math, so it kind of fits well.
Okay. Appreciate it.
For me, I'm doing engineering because I was good at math and science in high school and stuff and growing up. And then I really enjoy working and riding bicycles. So it fits right into a passion of mine to work in the industry as an engineer.
Yeah, I saw your response. I like that. It was one of the more unique ones, bicycles. So designing, optimizing, let me ask this. Do you use your bicycle?
Yep.
Any engineers out there unwilling to use the products that they design?
I would hope not.
I would hope not as well. Yeah, absolutely. I'm going to put something up here, and I've gone off of slideshow mode for my purposes right now. But I'm going to throw something up here. Let's go back to. You have no context for what this is, but I want you to look at this for a minute or so and comment on what are you seeing without knowing what this is. What's going on here? And take a minute, kind of look at the different interconnections and comment. Just kind of free for all comment on what is this? What's going on?
Looks like Aaron and Cody have put a couple things in chat. Tarek.
Okay. If you want to read those, it's kind of difficult for my format to read the chat.
Aaron says that there's a control volume. Cody says it looks like a diagram of how a ship functions. And Tarek adds, it looks like a web of subsystems within a ship.
Yep, all correct, by the way. What's behind this is miles and miles and miles of wire and connections of various sorts, electrical or otherwise, mechanical, fail safes, other things like that, batteries of different sources and different types, coming from and feeding different things. So what is feeding electricity to all of this? Because there's way more here, by the way, than it looks. This is a simple diagram, obviously, but even beyond the simplicity, it's way more complex than we could talk about in 2 or 3 semesters. So what's feeding all this electrically?
A nuclear reactor.
Okay. Yep. A reactor. And we'll talk about that, how that works in a second. What is the reactor giving it besides electricity? What do weapons systems need? What do IT systems need in order to stay functional besides electricity?
Cody says heat.
Okay, you got to do some heat and heat management. What do I mean by heat management?
Tarek says cooling.
Okay, yeah, you got to use the refrigeration cycle. Absolutely. You got to use it in a bunch of different ways, actually. What about the humans that are not shown? What do they need besides refrigeration and heat in many cases as well? Power. They don't need the power, but they need it to supply it. What do the humans need aside from those things?
Aaron says training.
They sure as heck do. Like Petty Officer Willhoite talked about, his school was at least 1.5 years long to get to a basic level. So they need a lot of training.
So Vanessa,
What else?
what do a bunch of people need sealed up in a big tube underwater?
Like what else do they need?
Yeah, what do they need besides cooling, heat, electricity for their machines? What do they need?
I mean, they need supplies like food, water, necessities. I mean, eat like that, really.
Yeah,
Besides
So-
the technical part of it, I mean, they need to live.
they do. So what do you need on a basic level to live?
Food, water, shelter.
You're missing something.
I'm missing something.
Yeah.
Um,
Hold that for a second.
Tarek's got the answer. Go ahead. And so does Aaron.
Okay.
yes, that is a basic necessity.
Absolutely. You need that too. The reactor has to do with those. And Petty Officer Willhoite will talk about that in a little bit. I won't bore you anymore with this diagram. All right, I'll turn it over here real quick. Thanks.
All right, so this is naval reactors, okay? So it's not just about our ships that you see on the top right or maintaining our shipyards so they do a lot of things. Top left, those are actually facilities out in Idaho, all right? So we got our dry storage facilities and our expanded core facility, okay? Then they also run BMPC, which is for Bettis, Knowles, that sort of thing. Then they're also incorporated with Bechtel as well. Right? And go all to the so they are the actual quality assurance and the driving force behind our nuclear power program, starting all the way from the bottom, going through the prototype training. That was that journeyman's thing I was talking to you guys about earlier, and the schooling that we go through. They actually maintain that the quality stays high enough for us to have never had a nuclear accident in our Navy. All right, they run all of our shipyards, going from the civilian side to the military side. They're in charge of all of the actual quality assurance and making sure that everything is done to a T with all of our maintenance practices. And then they're also in charge of all of our operations and training for our top right. All right.
So quiz question. Having said that, who governs naval reactors? Take a stab at it.
Brooklyn, any ideas?
So based on what Petty Officer Willhoite says, who manages naval reactors? Who's their oversight?
The government.
So it's part of the government, but specific, like who's the boss? Who regulates naval reactors?
The Navy.
Yes.
Oh, okay.
Why not the Department of Energy, who regulates
Oh, okay.
everything else having to do with nuclear everything?
What?
Why doesn't the Department of Energy regulate naval reactors? Open-ended question. You can take stabs at it.
Probably because it's contractor operated, so they're able to do their own thing.
So they are 1/4 contractor operated. Everybody else that's not BNPC and Bechtel, everybody else there is Navy. Like,
Oh yeah, that's true. Aaron said that they enter and leave U.S. waters.
okay, that's a good point. It isn't the reason. One of the things that Petty Officer Willhoite said is the reason. So is one of the two reasons. So there are two. There won't be a quiz at the end, but here's food for thought. One, we have never had a nuclear accident in the Navy. Have we had accidents? Yes. Never a nuclear accident. Has the Department of Energy had nuclear accidents? Yes.
Yes.
Not many, like 4, which is 17 better than the closest country. However, the other reason is why they operate independent of the Department of Energy is because they are a check and a balance on the Department of Energy. So just some side facts. You can probably get them off Wikipedia, but just FYI.
That's cool.
All right. And we could talk about all sorts of different kinds of ships, but today we're just going to talk subs. What do submarines do? Carry weapons, carry people, carry a lot of sensors. This is what they do. These are the 8 missions of a submarine. Strike warfare. What does that mean? It means they fire missiles at people. Strategic deterrence. Anybody? When you're talking strategic deterrence, there's a missile there, but what kind of missile?
A ballistic missile?
A specific kind of ballistic missile, nuclear ballistic missile. That's part of the triad of, that's our sort of anti-mutually assured destruction. They've got nukes, we've got nukes. That's what strategic deterrence is, and a submarine plays a role in that. Does anybody else know what those other acronyms mean? Or you want to take a stab at it? ASW? Anti-submarine warfare. Submarines are used to hunt other submarines as well. And then down in the lower left, ASUW is anti-surface warfare. What are submarines also really, really good at? Finding surface ships who can't see them. It's pretty awesome. SOF, Special Operations Forces. I'll show you some pictures in a second. ISR, anybody? That's somewhat more of a common one. What do you think that means?
Isn't it like intelligence, surveillance, and recon?
Absolutely, and reconnaissance. Yep, that is what we do.
Good job.
They carry a bunch of sensors and they go and look and listen, and they're really, really good at it. And I don't have pictures of that because I'm not allowed to. Counter drug ops, pretty self-explanatory, but it's pretty easy as a submarine to do that because they can't get you. They can't see you, and you've got all the tools and they don't. Mine warfare. Usually that involves divers deployed from submarines, but submarines are very active there as well. What else does a submarine do that's not on here? They travel a lot. So that's fun. A little more close up, left-hand side, missiles. They carry a lot of missiles of different sorts. Do they use them a lot? No, but if needed, they're there. And then right-hand side, the nose cone of several different submarines does open up. And that vehicle you're seeing on the lower right is a SEAL underwater delivery vehicle. I was neighbors when I was in Pearl Harbor with a good friend of mine still, and he worked as the intelligence officer for a SEAL unit that operated those out of Hawaii. And it's just a mini sub, and they dock inside a sub, and then they go inside and dry off, and they go somewhere else. A little more of a close up as they go outside the airlock. Where are they? They're in a lot of places, mostly the east and west coast, out Pearl Harbor, and then if you go across the Pacific, both in Guam and Japan. So that's that. Any questions up to this point before I turn it over to maybe the more technical discussion we'll have? Any questions or food for thought? It's all right. We'll have discussion in a second then.
All right, so we mostly put this up just to see the sheer scale of a submarine, all right? So if you look that little bottom right part where it's got the little white thing, so that fits about 6 people on board, and it's just a little shuttle going back and forth, okay? This is taking up effectively a city block of dry dock. Is about the size of how big these things are, all right? So this one's actually up in Puget Sound Naval Shipyard. My ship at this point was parked literally to the right off camera. So it's kind of cool. All right, so talking about the actual components making up a submarine, all right? So these are old pictures, mostly because we can't really show you updated ones. But just going forward to aft, so the very front of the ship to the back, you're seeing the cone with the actual sonar. You're seeing the living spaces, the officer, like with the officers up top, then enlisted down below with the officer berthing and crew bunks. That's just basic living quarters, all right? Going back, sonar, and you can see how it's literally all jam-packed full of what they actually need. Every single space has a purpose and a function. There's not really any extra storage space, okay? Then going aft even more, you get to your nuclear reactor compartment. That is entirely, there's no transit from the forward to the aft, or from the very front of the ship to the aft, unless you go underneath. Green part, that's all shield volume, so that engineers can actually get to where we work, okay? And then I've got a better picture of going into the actual engineering spaces. But so far, do you guys have any questions about the front, just the different spaces making up it? All right.
How many people did you say fit in that again?
So it depends on what submarine you're on. If you're on a fast attack submarine, so a non-ballistic type, you're looking at approximately about 120.
It can go up to 147.
And then ballistics are much larger.
How long do they have to stay on there?
So a ballistic submarine has a very set schedule. Basically, they go out for 6 months and then they're back for a year, and that's based on 2 different crews. So when one crew is out, another crew is, so half the ship is back while the other one's deployed. Ballistics, they will not pull into any foreign countries, and you're basically off the coast of countries that have nuclear weapons, just waiting for an order. All right. Then you come back and you're home with your family for a year, and then you go do it again. Fast attacks, they're out a lot, so their job is to not only accomplish all those missions, but they're protecting our aircraft carriers and other surface ships while they're out. So they are out on deployment for 6 months to 9 months, and every couple of weeks they're pulling into a different port. So with that, every port that they pull into, they're there for between 4 and 6 days typically, and with that, since they are smaller, they're actually able to pull into a lot of different ports that I wasn't able to being on an aircraft carrier. All right, so they can pull like upriver into different countries and actually port there.
So maybe deeper, how long are they underwater at any given time? Depends on the type of submarine. They can be underwater fairly indefinitely based on the capabilities they have. And we'll talk about some of the systems, the air, the rebreathing, all that other stuff. However, they can be underwater for months at a time, but typically they are not, a couple weeks at a time. Okay. They also like to see the sun sometimes, but typically they're underwater for a couple weeks at a time, 2-3 weeks. They'll loiter and then they'll come up, or they'll pull into a port. Does that answer a little more?
Yeah, I was just curious how long they were stuck under there. That sounds like a really long time.
Well, they can come up whenever they want, but
Yeah.
it depends on what they're doing.
Yeah. And you thought that being stuck at your house was a long time.
Yeah, I promise you, nobody on a submarine has coronavirus right now.
That's good.
All right, so let's go next slide. So this is showing the difference. That last one, if you kind of look, let's see, it's right here. They have all these Tomahawks, which are our fast attack submarines, right? On this next one, these are our ballistics. So all of these right here, these are all nuclear weapons. Okay. So that's kind of the difference in the different classes that's going on there. I know it's really blurry and hard to read any of those because I can't even read them. But the basic layout's effectively the same. It's just the sheer size with the type of weapons they're carrying is what's different.
So, quick question: what is what kinds of shielding precautions do they take when you're traveling around with that much nuclear capability in an enclosed space?
So they're going to have the same types of shielding that we actually have with our reactor compartment. So they're going to have not only water, lead, but they're also going to have a poly shielding, which is basically it's a plastic blend. All right. So between those, they're going to be able to shield from the neutron beta or radiation. The only thing that it really doesn't shield you from is gamma, but and that's just based on the sheer size of the gamma radiation. But in perspective, so I've been working around nuclear reactors, so not nuclear weapons, but nuclear reactors for the last 7 years up until this last year, so 6 years total. The amount of radiation I got was 200 millirem. That's my lifetime. The Department of Energy guidelines are 3 to 5 rem per calendar quarter, which means I've gotten over that entire period of time, I've gotten an extremely small amount compared to civilian counterparts.
That's the equivalent of taking 3 airplane flights to Europe.
That's how much I've gotten from my exposure. But yeah, apart from that, do we have any more questions about this one? All right, and so this is just going to kind of show different spaces and actually people doing their jobs. Okay, so this last one I just put up is actually our sonar, and that's what that's looking like. So this is with our sonar weapons. Okay, so this is like actually in and going in and finding enemies, all right, that are in the water. Do I know what all that stuff means? Absolutely not. I know that's what they're doing here, though. All right. Any questions on that?
We could do a whole other lesson on sonar. Sonar's fun. And the formulas that we use for that are very fun, but that's a completely different lesson. It could take all day.
Then these are our different classes of submarines. So going all the way back to skipjack, all right? And then right now we're making Virginia class submarines. So this evolution of submarines is they've gotten bigger and more strategic up until this last Virginia class, where it's actually a lot roomier than the previous classes on the inside. Okay. And the biggest difference, so that Virginia class, since 2006, we've been converting our teams over to being both male and female accommodations. Okay, so whether you're a male or a female, you can now serve on submarines without any barriers at all. So prior to it used to just be female officers. Now you can be female enlisted on a submarine. All right, and this is my bread and butter. Okay, so what So this is a basic diagram of a naval reactor plant, okay? You look on the left side, the red, that is the actual reactor system. What we do is we use a high pressure, high temperature system in order to produce steam for our actual steam plant. So does anybody know the process in which our reactors function? Like what's the underlying principle?
Yeah, just take a minute, look at the diagram. There is two sides. There's a closed loop on one side, and then what does this look like? A derivative of?
Who here has had thermal fluid systems?
I mean, I can try to. Do you guys just want to like have it explained what's happening in the diagram?
Absolutely.
Yeah.
Oh, okay. So the reactors creating heat, which turns the water or whatever liquid's there, probably one that goes at a lower boiling temperature, and then it turns it into steam, which runs the turbines, which then also looks like it goes to the propeller, but also a battery to harness some of the power. And then that steam is being condensed back into the liquid, so that way, and then pumped back up to the generator, so that way it can continue that cycle.
Absolutely. That was a really good explanation, actually. So we have two separate systems, just kind of like she was talking about. Okay, so we do not want radioactive steam going through and interacting with our people that are working. All right, that's why we have the closed loop reactor side that's all in red, and then the blue side is all steam. What we're going to do is we're going to use the fission process to superheat this water to right around 500 degrees. All right. Turns out at 500 degrees, you're making steam. So in order to have be able to transfer as much energy out of that water as possible into our steam generator, we pressurize that reactor to about 2,000 pounds, which is approximately saturation pressure and temperature. All right, so it's going to stay at the water. And it's from that steam, we're going to make. Okay. We're going to make steam, and that steam is going to have a pressure of approximately 500 pounds. All right. So it's also very hot. We want it to be dry steam. So at the very top of that steam generator, we have moisture separators. That way it's not carrying water droplets at 500 pounds pressure into all those curves and bends in our pipes. All right. From there, it's going to go into two different turbines. First one is the turbine generator. That's going to make our power. That power is going to be distributed to our battery, our motor generator, and distributed through the entire ship. Then we have our main turbine on the other side. If you look at that main engine throttle, it's exactly what it sounds like. It is literally a throttle in the pipes where if we want to go faster, we open up that throttle and it'll go, and the main turbine will go faster. If we want it to go slower, close it, right? It's going to go through a reduction gear process and actually going to drive the ship or submarine, in this case, through the water, all right, through that propeller. So big things on this, you've got your basic steam cycle, and if you guys know the refrigeration cycle, it's effectively the same thing where you've got steam being made and then being used and then condensed and pumped back into the steam generator. That way we're recycling water. Because we're not using salt water in this, right? We're using actual pure water. Going into this, and we actually make that pure water from salt water on board the ship. So on board, we have distilling units. We also have reverse osmosis units, and that's what they're actually going to use on a submarine is reverse osmosis for all of our steam being produced on there, and then also all of the drinking water on board. That way, we're not carrying on buckets of water for people to survive and underway. With that, any questions about this whatsoever? Pretty open book.
If you were given this and then given 20 minutes to memorize it, could you draw it basically after 20 minutes?
What do you think, Gershon?
I think I could. After 20 minutes, yeah, that's probably long enough.
You'd be surprised what you can do if somebody says you have this amount of time and in 20 minutes you have a test and you must draw this verbatim. It doesn't have to be pretty. It just has to be labeled and directionally correct.
Yeah, it could probably depend as well. When I am under pressure, I could do well
You'll be
comparing
under
when
pressure.
I'm
Don't worry.
pressured in just 20 minutes.
All right, so going back to another watch station, this is actual control. This is where they're going to be actually controlling the direction, the height in the water that the ship's going to be in, everything like that. All right. And maneuvering, I know it's got a Christmas tree right there. That's because that part is actually still classified because this is one of the prototype units. All right, but going from left to right, if you look on the left side, this is our actual, this is where our throttleman would stand. So this is the person that's literally in charge of the speed of the ship. That throttle in the diagram I showed you to either make the ship go faster, that's what the steering wheel open up those pistons and allow more steam to go through. Okay. Right here is where the reactor operator would sit. This Christmas tree is literally hiding rod height, power, or the amount of power being produced, and everything associated with the safeguards control of the reactor. Okay. Then right here, if you look down here on the board, this is actually all of the switches controlling this particular submarine as far as the electric plant is concerned. All right, so you would have down here would be your battery that we were showing, and this is where your battery would be dispersed out of. Okay, and then everything else is all of the actual system controls. So this person that would be sitting here is basically in charge of making sure every component on board the ship has power. They're also in charge of fire control. So if any of those those components of electrically disabling them, so that we can put the fire out, fix it, and bring it back up online. Anybody have any questions about this?
Justin, what's our time cutoff?
Well, we're set up till 1. Technically, we have till 1:15, but
We won't go back.
yeah.
This is battery well, so I have no idea who this guy is, but I'm 90% sure our MARF prototype power plant, this is the actual battery well associated with it. All right, that prototype is up in Boston Spa, New York, and it's old and in the process of being decommissioned. Just wanted to show you guys about the size of those batteries that we're talking about and how they're all in line.
Impressive.
We talked about women on submarines. It's actually been on for a long time, so I thought I'd put this here. Interesting thing about this comic was written by somebody that lives in Boise, so it's a little closer to home. And it's by Jeff Bacon. It's called Broadside, and he's a retired naval officer, and he just happens to live here. Circling back to the beginning, some of you gave me a definition of engineering, and I kind of put them all together. I liked it. Here's what the internet says about that. It says the branch of science and technology concerned with the design, building, and use of engines, machines, and structures. Okay, that's like a textbook example, but I liked what a couple of you alluded to, and that's the art of it. And that's the other definition, the action of working artfully to bring something about. Make it happen, figure out a way. That's engineering right there. And that's what I like about it. Let's see what else we got down here. What's going on in this picture? I know what's going on in this picture.
Did you take it?
I did not. However, I have a similar one from a very good friend of mine. Maybe a little bit of discussion here at the end. At the end of this PowerPoint, there's a bunch of advertisements for the Navy's nuclear propulsion program, which applies to sophomores through seniors. It's great. And we can talk about that if you want to, but I would rather talk about this. I sent a prompt that your instructor may or may not have you write about. However, I want to ask and get some feedback you got in the last couple minutes. Aside from a submarine being a weapons and surveillance platform, what systems does it need in order to support human life and comfort for weeks or months on end? So essentially, put yourself on a sub. What do you need to live on it? Underwater, you've got a nuclear reactor. What else do you need to design in order to live? Main systems, support systems that make the main systems work. And then here's the deal. How do you design them to be operated by people that are between the ages of 18 to 26 on average, with regular maintenance, make them last 40 years without any possibility of human life being damaged? Let's talk about that real quick. We got, first of all, what do you need? What do you need down there? We talked about it in the beginning.
Well, Tarek said you need air and water, and Aaron says you need showers.
Let's talk let's talk hygiene. Okay, tell me how you're going to make hygiene happen, because they do, and it's mandatory, and you need it. Just throw stuff out there.
I mean, you got to be able to take showers, brush your teeth, use the bathroom, and stay clean in general.
How are you going to make that happen? What does the reactor provide? What two basic things does the reactor provide? What are you seeing there?
Heat and energy.
We'll dumb it down a little bit more. Electricity and steam, right? What do you not need the reactor to provide? That's a basic element of life. What can you get from the world around you, put it through a machine, and make?
Water.
Water. Perfect.
Clean running
You
water.
can get that from a hole in the side of the ship, suck it in, put it through a reverse osmosis distilling unit. You have plain old good water. You need the reactor to provide electricity so you can make air. So you get water. Water supports showers, sinks, cooling.
I don't think.
How are you gonna make air? Tell me how you're gonna do that. You may not have thought about this before. That's okay, but throw out some ideas.
What do we have that has components that air is made of?
I guess water has some component that you could maybe utilize.
Okay, awesome. I'm gonna read you a quick thing. Anybody taking chemistry? Any chemistry in here?
Yes.
What level?
General chemistry 1 and level 2.
Okay, sounds good. So, there's, for the most part, nitrogen with some oxygen and a hair of a couple other things. When you breathe out CO2, and it's heavier than and eventually displaces the other, elements in the room, oxygen, etc. Or it overpressures, and you gotta relieve that. So you got to add O2 and take out CO2 and take out, what's a byproduct of breathing besides CO2? Imagine it's cold and you're breathing on a window. What's the byproduct?
Moisture.
Yes. You got to take water out. I mean, there's always going to be a little water in the air, but if you're in a submarine and there's 150 people breathing all over the place, you're gonna have a lot of water everywhere, and that doesn't bode well for a lot of machinery or for you. You can form oxygen through electrolysis of water. That's one way, but there's other things you can do using a couple different chemical reactions. How do you remove CO2 from the air? Use something that likes CO2, that traps it. Like, I don't know, there's different things, different derivatives of hydroxides and things like that. just chemistry. So I won't go into the whole process, but if you're at home, how do you remove moisture from the air? What can you buy from? I'm sure they're in stock right
Okay.
now too, because they're not flying off the shelves.
Tarek says a dehumidifier.
Yeah, that's it. Just a dehumidifier. And while those wouldn't necessarily work on a sub, it's the same concept, and we have dehumidifiers that are placed in various systems and areas of the ship that do that. So, hygiene, showers, flushing toilets, air. What else do you need on a ship? What does steam give you? What can you do with steam?
Maybe you can use it for like heat.
Okay, you can. You can. How do you and use it and leave all the trace amounts of moisture? You don't want to pump a bunch of wet air into the ship. You got to dry it out, right? Condenser, dehumidifier, things like that. Same thing. You just use it in a different manner. So we've talked about hygiene. We've talked about heating, cooling, refrigeration cycle, all that good stuff. What's something that you might run out of on a ship that you can't get from a reactor?
Oxygen.
You can make oxygen.
Aaron says food.
Food. Food is the one. Food is the one thing that is your limiting factor. Do they take a lot of food on board? Yes. The people that eat the best in the Navy, and we all eat very well, the people that eat the best are the people on submarines. They eat extremely well. And you know what? They deserve it. All right, maybe in the last 30 seconds, what do you get rid of? What do you need to get rid of on a submarine? We already talked about getting rid of moisture. Pump it back out into the ocean. How do you get rid of excess, CO2 or whatever? Just eject it, get rid of it. What else do you need to get rid of that you have to be very careful about? Two things.
Human waste.
Yeah, human waste, absolutely. There are people on board. Put things in, things come out. Human waste is one. And then what is the other thing?
Well, because it's nuclear, is there like nuclear waste you have to worry about?
Nope.
Oh, okay.
After 30 years, yes. You have to take it out of the submarine physically and dispose of it at a very remote site. And there are several in the United States. But no, while you're there, a submarine will last 30 years. A nuclear reactor will last 30 plus years.
Good job, Brooklyn. That's where I was headed.
Yeah, fantastic question. So human waste and what other? Just regular old garbage.
Aaron says food.
Yeah, just waste, food waste, garbage, anything like that. Yeah. What do you do with it until you come up to the surface? Do you pump it out into the ocean?
No.
No. Heck no. You compact it and you save it, and there's space specifically for that. But because of that, they're very judicious about what they take with them and what they don't take with them. What are some other physical needs down underneath as far as maintaining your health?
What about staying physically fit?
Yes, that is something that they need to care about, and they do. So there are different auxiliary spaces and different engineering spaces or torpedo spaces. And when you go on board a submarine, you will find that there is a treadmill or a stationary bike or a rowing machine or every which different machine or a Bowflex or a weight bench stashed in every place available. It's kind of amazing. And they have plenty of workout areas, but they are put in there. The room is not made for them, but there are places, and you put exercise equipment all over it. You can take advantage of that because it could be very sedentary, but every sailor has to work out. Every sailor has physical fitness standards. Would I much rather work out on an aircraft carrier? Yeah, I mean they have gyms and they have a lot of running areas and other things like that. However, on a sub, there's plenty of ways to work out. And basically, just like an engineer, you find a way, artfully find a way to make it work, right? That's how it works.
So I have a question from the human psychological perspective. How do you engineer an enclosed space like that to be conducive to people staying mentally and emotionally healthy when they're cut off from natural light and fresh air and that type of thing for long periods of time?
Fantastic question. I hope I'm not off base on this, but I wonder if instead of the prompt I sent you, if that could be the prompt.
That could be. I can let them make that choice.
There are answers to that. However, I wonder if I could respond after the fact to the students' thoughts.
Okay. So that I think is going to be an interesting topic for you guys. It might involve a little looking around and digging, but let's make that our writing assignment this week is how do you engineer an environment that is conducive to human life in an enclosed space? Because, we've talked about food, we've talked about, the mechanical parts of keeping life going, air, water, that type of thing. But the psychology of a whole bunch of people living on top of each other, you got to engineer that into the mechanics of that. How do people feel about that as a topic?
I think that sounds like a pretty interesting topic of discussion.
Okay, cool. Yeah, it's one I hadn't thought about until just now, but I think it's something that an engineer because with submarine design, you're not only having to look at the mechanics, but there's a little bit of the civil engineering mentality too, of how do you build something that people can work with in living conditions and the psychology and physical needs and that sort of stuff of people. So let's go ahead and do that. I'll put it in writing on the Blackboard site so that you have a reference point. But I think it would be an interesting thing to look into.
And what I'll do as well, and I apologize for putting you on the spot like that, I will send you a couple of articles on that very thing.
Great, I'll share that with them.
What else? That was pretty much the stuff we wanted to impart. Again, we can go on and there's some advertising things, but I can just send that to you and you can have that. But
okay, I can pass that along. I do have a question though. When we talked before, you were talking about the weapon systems and that sort of stuff. I'm not quite sure how I want to phrase this now.
Sure.
When you've got a submarine with nuclear weapon capability, how often do you run simulations and tests? And does that involve any moving of the actual weaponry, or is it all simulated?
So that I can kind of touch base on. So with most ships, what they're going to do is they're going to do biannual testing. It doesn't actually mean that they're going to be launching a live nuke. It means that they're going to be actually testing out.
Oh, I think your mic's cutting out there.
Of their ballistic missiles that are right. Say again.
I think your mic's been cutting out.
All right, we'll try it again. Go ahead.
All right. So with the ballistic missiles, what they're going to do is most of the time it's semi-annual, but they're going to launch a ballistic missile that the warhead's actually been taken out. So they'll do that missile testing. That way they know that their systems are still accurate. They know that their systems are still going to work and everything like that, apart from the actual nuclear weapon part.
Okay. Does anybody else have any questions?
What about questions about stuff we haven't even covered?
What's been one of the biggest, like, or if there has been innovations in the last 50 years or with submarines?
Let's see. One of them on the weapon side is the capsule launched missile. Submarines do not come to the surface to launch missiles. They launch a missile inside an air bubble. And then when it breaks the surface, the rocket motor, the first stage engages, and then it's off. So on the weapon system side, I would say that's probably top 4. Is the capsule launch system. And you can Google that. It's very cool to watch. But I wondered that when I joined the service and wondered how the heck they launched from under the water. The most important sensor system on board a submarine is the sonar. A sonar array on a submarine is far superior to anything on another ship in terms of sonar because they use it for 2 things, tracking and weaponry and navigation. And those little green lines that we showed you on one of the previous slides were some things that they use in a couple algorithms to track other submarines. However, through the water column, that is not what the navigation sonar looks like. And I'm not allowed to show those pictures. They'll be declassified after, I think the normal statute is 50 years. However, sonar, navigation sonar is so sharp now that they are better navigators than looks up top windows.
Okay, we have a question from Tarek. How fast can the subs go?
Well, there are 2 answers to that.
Fast and slow?
Above the water or under the water? Above the water, you have some surface tension and things, and they generally do about 12 knots on top. Under the water, the Wikipedia answer is 30 plus knots.
That's interesting because you would think that under the water you would have much more resistance because you have much more surface area that's passing against the water versus air.
They are much faster underwater for a couple of reasons based on what
you're
they right while they're at the surface.
Okay,
because they can operate different things when they're at the surface that they can when they're under the water that aid them. But also they have different they use in some ways depending they can use their auxiliary propulsion when they're at the surface versus underwater they can just go.
Cool.
That's kind of a layman's answer, but that's all I got.
That's okay. I'm a liberal arts major in an engineering school.
Perfect. What else? Hopefully after this, you know everything there is to know about a submarine. Sorry. Even we don't know everything there is to know about a submarine.
Yeah. You already told us it would take 3 semesters anyway.
It probably would. I mean, that's how long it took you to get through your power and protection. That's entry level. But if you like South Carolina and crocodiles, that's where the first section of submarine school is, or alligators rather. They don't have crocs down there.
Okay, so moving into recruiting mode, what are you looking for if you're looking for a naval nuclear engineer?
We are looking for somebody that's not simply scholastically sharp. The minimum GPA is 3.0, but as you go north toward 4.0 makes you more competitive. We're looking for somebody that's well-rounded. Civic, volunteer, clubs, societies, sports, well-rounded individual. Somebody that doesn't have a criminal record. Because if it's
Okay, you guys are cutting out again.
Naval officer. So, in general, scholastically sharp and well-rounded. You have to have a resume, more than simply, ideally more than simply academic. About half to 2/3 of nuclear propulsion officers in the Navy are some sort of an engineering major, whether it's mechanical, electrical, etc. I'd say the biggest set are mechanical engineers, but there are others. And then there are physics, math, chemistry. Right now, there's a history and philosophy guy who also really liked calculus and physics. And so he took a year and a half of calc and physics, and he's a nuclear propulsion officer down in Georgia right now. But that's the rarity. Usually they're engineers or physics and math.
Other questions, guys? All right.
So here's a caveat, maybe, Justin, on that note. This is one of the only 2 programs in the Navy where they will pay you as an undergrad. So civil engineering and nuclear propulsion program, you can be, as long as you have 2 semesters of physics and 2 semesters of calc or more, you can apply. Other than that, you have to wait.
It's also one of the few programs enlisted side. So if your GPA is under where it needs to be as far as college goes, they will pay up to $60,000 of your student loans, a $38,000 signing bonus right now.
So there you go. Monetarily, it's good, and then otherwise, it's challenging and amazing.
I know a couple of our alumni who have gone through your program, and they used it to offset school, and when they came out, they had prime opportunities for moving into industry in a lot of different ways. So it was a good program for them.
Yeah, if you want to come back to Idaho afterwards, there's a lot going on in Idaho that would love to employ you.
Okay, well,
all right.
Well, thank you guys. I appreciate your presentation. This has been really informative. I know I've learned a lot, and I've appreciated our interaction with our students. You guys, everybody give them a quick thumbs up or check mark. Tell them how much we appreciate them, and we'll say bye and thank you very much.
It's been a pleasure.
Okay, thanks, guys.
Take care.
Thank you.
And for the rest of you, I will be in touch with you on Blackboard and email, and I look forward to hearing what you come up with on your writing assignments. So take care, you guys.